Hello guys, in this video we are going to see the solution for the Hbc-2017 coding practice set 1 question number 3, that is desolate and supported numbers. So what is a desolate number? A number is said to be a desolate if it cannot be represented as a sum of a positive number x plus number of active bits in binary representation of x. A number y is said to be a supported number if it is representable as a sum of positive number x plus number of active bits in binary representation of x, that is, x is supporting y. So, how we are going to deal with this problem? First, let's consider the input number 3. So, what all numbers we need to consider to check out whether 3 is a desolate or supported number? One simple observation is that any number n greater than 3 will not contribute to the sum 3. For example, consider the input number 4. The binary representation of 4 is 1 followed by 2 zeros. So the number of set bits in binary representation of 4 is 1. So 4 plus 1, that is equals to 5, and 5 is not equals to 3. So we are going to discard 4. The same thing happens for any number greater than 3. So we are simply discarding the numbers greater than the present input value. So for the number 3, we are going to consider only those numbers or less than 3. So those are 0, 1 and 2. So for any input number n, we need to consider only those values which are less than n. So let's take the input number as 3. So for 3, we are going to consider the values 0, 1, 2. So let's start with 0. So 0 plus the number of set bits in 0. We know that the binary representation of 0 is a string of all zeros. There is no set bit in binary representation of 0. So 0 plus 0, that is equals to 0, and 0 not is equals to 3, so we are going to discard this number. Next we are going to continue the same with 1 plus the binary representation of 1 is 0 followed by a 1, and the number of set bits in binary representation of 1 is 1, so 1 plus 1, that is equals to 2. Next, so and 2 is not equals to 3, so we are going to discard 1. Next, the same we are going to do with 2. So 2 plus the binary representation of 2 is 1 followed by 0. So the number of set bits in binary representation of 2 is 1. So 2 plus 1, that is equals to 3, and which is equals to our present input value. So 3 is not a desolate number. 3 is a supported number, and 2 is supporting 3. Now let's see an example for the desolate value. Let's consider the input 4. So we are going to only deal with the numbers which are less than 4, and those numbers are 0, 1, 2 and 3. Let's start with 0. 0 plus, as you know, the number of set bits in binary representation of 0 is always 0. So 0 plus 0 is equals to 0, and 0 is not is equals to 4, so we are going to discard 0. Next, consider 1. 1 plus the binary representation of 1 is 0, 1, and the number of set bits in binary representation of 1 is only 1. So 1 plus 1, that is equals to 2, and 2 is not equals to 4, we are going to discard 1. Next, consider the input value 2. 2 plus the binary representation of 2 is 1 followed by 0. So the number of set bits in binary representation of 2 is 1. So 2 plus 1, that is equals to 3, and 3 is not equals to 4, we are going to discard 2. Next, consider the input number 3. 3 plus the binary representation of 3 is 1, 1, So the number of set bits in binary representation of 2 are 2. So 3 plus 2, that is equals to 5, and 5 is not equals to 4, so we are going to discard 3 as well. So for the input number 4, none of the numbers less than it are supporting it. So according to our problem statement, 4 is a desolate value. So how are we going to code it? So I am going to write this main function, that is bool is desolate, which takes an integer parameter n, stating whether it is a desolate or supported number. So if it returns true, then the number is a desolate number. Otherwise, if it returns false, the number is a supported number. So let's code this. So let's initialize int I is equals to 0 for indexing purpose. So for not necessary. So for I is equals to 0, I less than the present input value n and I plus plus. So if I plus count set bits of I is equals to n, we are going to return false. What this condition states is, so if for any input value I less than n, if I plus the number of set bits in I, if it becomes equals to n, then we are going to return false. Returning false indicates that it is a supported number, so it can't become a desolate number. So if any of the input values can't be a supported number, then can't support the input n, then n is a desolate number, so we are going to return true. So for count set bits in 10, let's take a count variable, let it be unsigned, so we are going to take only positive values. Unsigned int count, let's initialize this with 0. So while n, so we are going to loop till n not becomes equals to 0. So I am going to increment the count only if an set bit is encountered. How we come to know if a set bit is encountered or not? For example, consider the input number 2. The binary representation of 2 is 1, 0. Next, and we are doing and 1. So and 0, 1. The binary representation of 1 is 4. This leads to 0. So for 2, initially we are not going to increment the count. The next step is n. So we are right shifting the present input value n by one position. This means 2 is right shifted by one position. The binary representation of 1 is 1, 0. So if we right shift it by one position, it becomes 1, 0 becomes 0, 1, which is 1. Now as n is not equals to 0, again we are going to enter the loop. Now count is equals to count plus n and 1. So n is 1, the binary representation of 1 is 1. We are going to do a logical AND with 1. So 0, 1 and 1, which is equals to 1. So count is incremented by 1. Now we are again right shift the present in n by 1. So 0, 1, if we right shift, it becomes 0, 0, which is 0. So the loop operation is break. Now the present value of count is 1, so we are going to return it. Return count. And this is the actual code.